here we go. Taking the derivative of an integral on a defined interval. Going to apply the second fundamental theorem. Okay, if we look at what the second fundamental theorem states, we've got some function that we're applying all this stuff to. We're going to take this top function here. Apparently, we're going to plug that into the function. So, if I set this up, I'm going to take my top function, which is x. I'm going to plug into my function here for the variable t. If I do that, I get the cube root. T becomes that x, so x to the fourth, plus 5. That's the plug-in portion. If I go back here for the rest of that first piece, after we plug in, we're going to tack on the derivative of that function we plugged in. So we plugged in x. The derivative of x is 1, so we tack that on. As that theorem continues, we subtract. Now what we subtract is a real similar idea, only now we're focusing on this bottom function being plugged into the original function, right? That's what this piece here represents. So if we go back, we're taking the cube root, because that's from the original function. We're replacing t with this bottom function, the constant value -1. So -1 goes in, it'd be -1 to the fourth if I wrote it all out, plus that 5. But now you're going to tack on the derivative of that value you plugged in, right? So tack on the derivative of this -1. What is it? It's 0. So really this second piece, because I'm tacking on a 0, goes away. And all I'm left with is the cube root of x to the fourth plus 5. So I started with the original problem there, gave me this part here, which simplified equals this. All right, for this second one, we'll take the derivative, apply it to an integral, defined on an interval, -x² to x². So basically, those are my two functions I'll be playing with and plugging in here for the second fundamental theorem. We apply all this to a function of 1 over 8 plus t². Got our dt at the end. Follow the same steps as before. We start with this top function. We plug it into the overall function here, and we replace any variables of t that we see. So again, I just have the one variable of t. I would have 1 over 8 plus, well, let's see, x² goes in for something that's already squared. So this is going to be x to the fourth, exactly. So we plugged in that top function for t. Now we take the derivative of that top function. We tack that on. That derivative of x² would be just 2x. That concludes all the business we have with that top part. Now we subtract.
Wait, take the derivative.
All right, now we're subtracting, taking this bottom function, we're plugging this into the overall function for t. We're going to have 1 over 8 plus. Again, we're squaring this idea we're plugging in, so the negative goes to positive. We're squaring something that's squared. This is also going to be x to the fourth. If you tack on the derivative of this bottom function, that's going to be just a -2x. We do a little housekeeping. Well, basically, this 2x slides to the top. This -2x slides to the top. And for our convenience, we have common denominators, right? We've got a common denominator of 8 plus x to the fourth. So we know if we're going to put this all together, 8 plus x to the fourth is in the denominator. We've got a 2x minus a negative 2x, right? So 2x plus 2x. Get 4x. 4x over 8 plus x to the fourth. That would be our answer, applying the second fundamental theorem.